Hello everyone, this is Ajay, one of your TAs for Comp 423, and in this video I'm going to be going over the Quiz 2 system design practice that was sent out on Canvas. So this particular practice PDF contained 4 questions following the system design question format that we went over in the review session on Monday. First off, I did release, if you haven't seen it already, all of those when you submitted your pictures of what you did in the CL30 exercise. I went through all of them and gave feedback for all of the ones that I could read, and I released that on Gradescope. So if you are interested in seeing how you did on that, and to see if there's any feedback on things that you could work on or improve for the quiz, definitely check it out. But we're also going to be going over the same type of questions in this video too. And I'm kind of going to be talking about what to expect, because what is in this particular document, there are a few things on some of the questions that might be out of scope for the quiz, but it's still useful to think about. And if you're able to work through that and you were able to solve it, then you should be in a very good position for the quiz. Now, this video will be broken up into chapters, which will be timestamped below, so you can jump from question to question if you would like. If you want to work on one question and then watch that part and then wait and kind of split up the questions, that's also fine. Or if you want to do them all at once, anything works. So I'm going to get started here by going to the first question, which was regarding the ordering system for the e-commerce store. So I'll be reading through these questions and then I'll be showing the diagram, and I won't necessarily write out the exact words here for the explain your decisions for the relationships, because I will be talking about it. However, I will release the PDF that I worked on Canvas after the video is posted, and in there I will also fill this in. That way you can see how we might expect some justifications for this. Okay, so this particular question is asking, so we have been tasked to design the backend database schema for an e-commerce store's online ordering system, right? So this is just an ordering system, and we're given 3 tables that we need to use, which are the customer, product, and order tables. So you can see here that it says a customer represents a customer of the store, product represents a product sold by the store, and then an order represents a single order by a customer for a product. Okay, so that's the tables that we'll be working with here. Of course, to remind you of the expectations, you will be filling in at least 4 fields. So 4 fields for the table. We need to make sure that we include data types. And then for primary keys and foreign keys, we will use either the asterisk or the caret. And then, of course, tables that are related, we will draw an arrow between them, and then we will label it on the type of relationship that we want to include, right? So you can see this is an example of a valid diagram, where primary keys we mark with an asterisk, foreign keys are marked with a caret, and then we have an arrow in between these 2 tables specifying what type of relationship we are choosing. So when we're going through these type of questions with customer, product, and order, I think a good place to start is actually thinking about how these might be related and what type of relationships we might have between these tables. Doing that first, rather than coming up with fields, might be useful, because if you need to, for example, have foreign keys in any of your tables, if you know the relationships between the tables beforehand, it will be easier to get all of that set up, right? So we have customer, product, and order. And the wording here is, might lead you in different directions when it comes to what type of relationship we want to have, right? So we have a customer, which is just, a user of the website, product, which is just an item sold. And so the order, which is where it says represents a single order by a customer for a product, that is where, it becomes more apparent that we might need a relationship, right? Because we're talking about that an order, right, is by a customer and for a product. So we can see that order is kind of connecting these 2 pieces, the customer to the product. And so because we are connecting a customer to a product, we might imagine that our order, so if I were to draw order here, might be in between the customer and the product. So we have customer and product, and we have our order. the order are connecting these two things. And so we need to have a relationship between our customer and our order and our product. And this makes sense because a customer, will have orders and an order will have products on it. And so now that we've kind of defined the structure, what type of relationship might we work with? Well, a customer to a website, say that you go on Amazon, right? You don't just place one order when you go to Amazon and that's it, right? You may place many orders throughout the weeks or months. So it makes more sense for a customer to be able to place multiple orders. So in our relationship, we would want to say that there's some sort of many relationship, either a one-to-many or many-to-many. And so we have those two options, one-to-many and many-to-many. And we can consider that, well, generally when I'm placing an order, it's just one person ultimately that's paying for the order. And you're delivering it to one place usually. So it might make more sense to have a one-to-many relationship here. Simply because, we have one customer can order many things, but an order is probably just placed by one customer. Now, if you were to say that, well, maybe two customers can place one order, like maybe there's some way that we can do that, then that is fine. You just want to make sure again that you justify your answer in that relationship box where you're, defending the relationship that you chose. Of course, there is not necessarily going to be one correct answer, and we will actually see that with the next relationship too. So as long as you provide a good justification, that is really all we are looking for. It's not going to be like just because you chose a many-to-many instead of a one-to-many, that it's going to be completely wrong, right? It's just, as long as you're able to reason through why I chose that type of relationship and maybe give an example, then everything should be good. And so that's the next thing. We need to choose a relationship between order and product. And now the wording here is a little bit weird because it says that it's representing a single order by a customer for a product. So there's two ways to interpret this. And again, depending on how you justify both answers are right, you can either say that, well, this is like a single order by a customer for one product. So therefore an order should just have one product only on it. Of course, if you use the intuition for designing like an online ordering system, you would probably know that, well, an order has multiple products on it. Most people are ordering more than one thing, for example, on Amazon when they check out. And so either a one-to-one, if you're following this for a product, or potentially a little bit more intuitively, a one-to-many would be fine here, where one order can have many products. And one product one product would match to an order. Now, would we want to have it such that like a one-to-many where a product ultimately maps to just one order, or would we want it so that products can map to multiple orders? And so it probably makes more sense based on, again, the context of this, to say that one product can be on multiple orders, right? So for example, if I'm trying to sell a bottle of toothpaste, right? For example, one person, that bottle wouldn't just be sold to one person. You might have, it would be sold to one person, but like once you sell it to one person, you can also sell it to other people, right? Multiple orders can be ordering the same product. So in that case, we probably end up with a many-to-many relationship here between order and product. So now that we know our relationship types are one-to-many and many-to-many, we can also remember to think about where we're going to place our foreign keys. And so remember, we said that in a one-to-many relationship, so either we have three relationship types, one-to-one, one-to-many, and many-to-many. In a one-to-many relationship, we place our foreign key on the many side. And we talked about this in the review session, why this is the case. But remember that we cannot store a list of items in a database column. And so if we were to have the foreign key on this side, you'll see that my foreign key placed on the one side would have to match to many different items on the many table. And so what you'd end up having is you have to store a list of IDs to account for all of them. And we cannot put lists in our columns. So instead, we put our foreign key on the many side. If you're a little bit unsure about this, I highly recommend checking out the recording for the TA review session on Monday, because we talk about this in more detail. Now, another thing that came up a little bit with the with the diagrams that you all submitted was a lot of people did end up putting foreign keys in the many-to-many relationship. And it's important to remember that in a many-to-many relationship, we run into the same problem on both tables, right? If we were to put the foreign key, let's say on the left table, well, I'm going to be mapping to multiple items on the right-hand side. So this would mean that if I wanted to, for example, point to items 1, 2, and 3, I would have a list with 3 IDs in it, which is not allowed, right? We cannot do this. And likewise, if we do it the same way on the other side, where we have just a foreign key which points to 3 items, we run into the same problem. So in a many-to-many relationship, recall that we have an association table between them usually. So if we have table A and table B, and we say that there's a many-to-many relationship, really what this is saying is that we'll have some table in the center which matches the IDs. So you'd have A and then B. And this ensures then we have 2 one-to-many relationships where we have two foreign key columns, one that points to items in A and one that points to items in B. And this avoids this problem where we're pointing to multiple items, because you can see here, if I have a foreign key, I'm only pointing to one item in B. If I have a foreign key on the left, I'm only pointing to one item in A. I recommend checking out the SQL Alchemy reading, specifically the relationships chapter, for more details on this if you are a little bit unsure. But the summary here is that foreign keys are in this association table. Now, if you remember in the instructions, we mentioned at the top here that if you are specifying a many-to-many relationship, you do not need to draw the association table in your diagram. So if you have a many-to-many relationship in your diagram, you do not need to specify foreign keys in your diagram because they would be in the association table, which is hidden. And then lastly, for a one-to-one relationship, either works, but you want to only choose one. So you can either put the foreign key in the left or foreign key on the right, but not both. So knowing this, and this is a bit of background which will kind of make the rest of the questions go a lot faster too. If I'm looking at these two relationships, well, I have a many-to-many here, which means there'll be no foreign keys because it's in a hidden association table. Here we have a one-to-many relationship though, and we said that the foreign key goes on the many side of the relationship. So we can place a foreign key in our order table, which would then, point to our customer table. So this would point to our customer table. So this is kind of a rough sketch, and now we can go and actually draw this out. So we have a customer, product, and order table. And we said that between my customer and order table, I have a one-to-many relationship. So I have this is like a one-to-many relationship. And I have a foreign key in my order table, so I can mark that, I have a foreign key, and this is going to point to my customer table. And I can say, for example, this is called customer ID. Remember that foreign keys point to primary keys in another table. So if we have a foreign key, which is pointing to our customer table, and foreign keys point to primary keys, we then need a primary key in our customer table. So I can include one here, and I will mark it with an asterisk, and I'll just call it ID. In fact, it probably makes the most sense to have an ID, a primary key, on every table. So because in most tables, you always have a primary key field in the table. And this actually makes it easier because you're asked to specify 4 fields in this type of question. And in reality, you can just put ID for every single table. So in reality, you only really have to come up with 3 on your own. You can have ID always there. Right? So we now have a foreign key pointing to our customer, establishing the one-to-many relationship. And then we can, of course, put our many-to-many relationship. So many-to-many relationship between order and product. And now finally, we can just fill in extra fields, whatever we think would make the most sense. So for example, customer, I could have like first name, right, last name, and let's say mailing address, right, mailing address. And anything we put here works as long as it makes sense for the problem, right? This is, you can come up with anything, what you think is important. All right, but for like in product, I might have a name, I might have a price, and maybe I have a description. And then in order, maybe, so I have an ID. What else could I store in an order? I could put the timestamp, right? So when the order was placed. And perhaps I can also include, let's say, I don't know, what else could work with an order? Maybe gift wrapping, right? Sometimes when you place an order, you want it to be gift wrapped. So I can say, needs wrapping. Great. So there we go. You can see that we've created our diagram. We have our arrows, we have a foreign key and primary keys marked, and we have 4 columns for each of our tables. And then of course, the last thing is we just want to make sure we supply types. So ID, we can say int, first name, string, last name, string, a mailing order string. That makes sense. For order, same thing. We can just have a numerical ID. So my marker here has bugged out. All right, we're back. For some reason, my marker stopped working, so I had to restart the app. Maybe we can continue here. Timestamp we can actually put as a date, and that would be valid. You could put date or string or something. Needs wrapping makes most sense to be a Boolean, and then customer ID is an int. Now remember, with foreign keys, because foreign keys point to primary keys, you want to make sure that the name or that the type that you specify here. So for example, the type in the foreign key here should be the same type as the primary key that it's pointing to. And then here, of course, int works, string works, double works here, or float. And then regardless whether you use double or float, it's perfectly fine. I'll write float because I think that is what the type is supposed to be, but if you write double, we will not take off for that. And then string for description. And there we go. That is a pretty valid diagram for our first question. And of course, here you will then want to specify some description for each of these relationships, which you can do in this piece. So you could, like, for example, just label this 1 and 2, and then write like 1 and then 2, and that would be perfectly valid. All right, so we're going to move to the second question. Now, this one is a little bit more difficult, and the kind of the feature here, the gimmick that is required to get this to work, is not something that you will necessarily be required to do on the quiz, but it is an interesting thought experiment and actually a real problem that a lot of students had last semester. So the friendship system was a final project idea last semester, where students could choose friends and send friend requests and create a friendship list. So here we're actually only given 2 tables, and we just need to specify the relationship between these 2 tables. So we have a student table, which represents a user on the site, and then friendship, which represents a single friendship. And the key thing here, between 2 students. Between 2 students. And it's the same requirements down here as before. So when we're modeling this, we have students, which I'll mark with S, and then friendship, which marks as F. And, there's obviously some sort of relationship here. Now, it makes sense if you were to put a many to many here, that would technically, that might work because you are having like maybe one user to many friendships, and then friendships to many users. But it's also kind of important to think about what we're actually doing when we're creating this, right? Our friendship table is really just linking 2 students together, right? Like if I have a student A and a student B, both of these people are part of this friendship connection. So in reality, if I were to draw a sketch of this, so if I had like friendship and then I had student. So let's say I had student here. Let's just give an ID. Let's say this is my primary key column. I have 3 students. Then in friendship, what am I really doing? Well, I'm connecting, say, friendship or student 1 to student 2, right? Because let's say that I'm trying to create a friends between these 2 people. I would say, well, I'm trying to connect student 1 to student 2, where student 1 is pointing to, the student in the student table, and then ID 2 is pointing to the second student in the table. And you'll notice that this is kind of weird. It looks a bit strange because we have 2 arrows. We have 2 different tables that are pointing to this, or we have 2 different columns that are pointing to the student table. And this is actually a valid construction. So it is possible, of course, to have multiple foreign keys in one table that point to other tables. You have probably seen that in your final projects. But it is also possible to have a foreign key point to, or it's also possible to have 2 foreign keys pointing to the same table, right? So I have like person A and person B, and these are both pointing to students. And this is actually very similar to the many-to-many relationship that we talked about above in the diagram. Let's see if I have it right here, where we kind of connected A and B through an association table. So you could think about this friendship table actually acting like an association table. So you'd ultimately have, right, a student, and then you'd have your friendship, and then you'd have student again. And so ultimately, you're creating a many-to-many relationship between 2 students via this friendship table, which would be a one-to-many and one-to-many relationship. And if you think about this in how your object would look like when you're pulling it from the database, this does make sense, because if I were to pull a user object, or a student in this case, a student might have many things, right? It might have name, it might have their email, but another field could be friends, right? And this could be a list. Now, what is the type of friends? If we said name was a string and email was a string, well, friends would be ultimately a list of students, right? So we are having this nested kind of relationship where we have the student object can point to many other students as well, right? So I could have, for example, student A, which I'll just say student 1. Let's say student 1, and their friends are student 2 and student 3. And I could look at student 2, and student 2's friend might be just student 1, right? And you can see that this is perfectly valid. However, the objects that I'm pointing to in this list are the same, they share the same type. They're all students. And so this is a valid way to think about it, that we can just use our friendship table to link 2 students together and create a many-to-many relationship between these 2 items. Now, of course, it's weird here because both of these are the same table, right? They're both students. And so we essentially collapse it down into this, we collapse this down into having student and friendship. And then notice how we have a one-to-many and a one-to-many relationship. We have 2 one-to-many relationships. We can actually draw that like this, where you have a one-to-many and then you have another one-to-many. So this is also a perfectly valid answer. And actually the solution, if you were working on the final project last semester, this is how you'd ultimately need to set up the friendship system. And there is actually a branch, I believe, on the CSXL repo right now that has this entity structure laid out. So if you're interested, I highly recommend going to GitHub and trying to find the friendship branch. And it's actually set up this way, which is pretty cool. Of course, there's a lot more technical things in SQL Alchemy that you need to do in order to get this working right. But this, at a high level, would be the entity layout. Now, if you did just do this, a many-to-many between student and friends, that is fine too. You just want to make sure that you talk about why this relationship, why this would be right in your justification section, and kind of talk about your choice there. So I have my student and friendship, and I'm going to draw out the example that I gave with the two one-to-many relationships. So we have, of course, it's always a good idea to give both of our tables an ID field. And then in friendship, I might have a timestamp as well, like when I became friends with somebody. I could include like first name, last name, and email as my field. And then I can draw my arrow. So I'm saying that I have a one-to-many and a one-to-many relationship right here. And so because I have two relationships, I need two foreign keys. Remember, foreign keys, when we use a one-to-many, we need to include one. So if I have a one-to-many and a one-to-many, I need to include the foreign key on the many side of the relationship, which would be the friendship table. So I can add my first foreign key, and I could just say like student one ID, or like student A ID, because this would be like student A. Again, going back up here, we have a, we had student, kind of said that this was like student A and this was like student B. So we'll have student A ID, and then we can just add another foreign key for student B ID. And this is a perfectly valid arrangement. Of course, I need to include my types. So this would be an int, a string, a string, a string, int, date. And technically this would be date time, but if you include just date, that's perfectly fine. Int and int. And this is the official answer for this question. But again, if you did a many-to-many relationship, or maybe you did something different, as long as you justify it, that'll be perfectly fine. Now, this particular piece, I don't want you all to feel too stressed about this, because if you didn't get this where you'd have kind of two foreign keys pointing to the same table, you will not have something like that on the quiz. So I want to stress that. But it is a very good thought experiment for your final projects, and also because it kind of confirms the fact in your mind that a foreign key, you can have two foreign keys pointing to the same table, and that would be valid. So that might help your understanding about foreign keys. Also, again, I recommend checking out the friendship branch in the CSXL repo to get a better sense of how this would actually be coded up. And hopefully that even though this piece is not something that will necessarily be quizzed on, we hope that it will still help you think about these relationships and to give another example, and a more complicated example, in trying to work through it and come up with column names and foreign keys and primary keys, etc. So this is the official answer, but if you did do just like a single line that was a many-to-many, and then you just justified it, that would be perfectly valid too. And in the PDF download, I might also include that at the bottom here, just to show in case you didn't do it this way. All right, so we're going to move to the third one. And actually, I like the third one a lot. So this is kind of a, this may be something to remember. Question 3 is probably the most similar to the one on the quiz that you can expect. So on the quiz, you will be having 4 tables that you will connect. And there's not going to be something more intense like this. This is the reason why in this question we only included 2 tables, because there was there's a more complicated relationship here. But 4 tables, that is what the quiz will have. And this is also more of a fun question. You can actually think about this because a lot of people like Spotify. How would you actually design a backend system for something like Spotify? So we're given 4 tables. We're given a user table, which represents a user of Spotify, songs, which stores songs. Sorry, the errors would go here. And then we have artists, which is someone who, I guess, sings the song. And then playlist, which is a single playlist created by a user. And we have the same requirements as before. And actually, for this one, I'm going to scroll down and we're going to just look at this here. I've written out all 4 tables: user, playlist, artist, and song. And when you're dealing with 4 tables, it can be a little bit more, there's more relationships that might go on. So let's think about this. if I just choose two tables, like user and artist, would there really be a relationship between user and artist? Well, there might not necessarily be, an obvious one, but you could think about that, well, maybe a user would have favorite artists. And so maybe I want to favorite the artists that I like, right? That might be a valid type of relationship. And so whether you include a relationship or don't, that is okay between these tables. But if you do include one, such as here a many to many, make sure that you justify why. So I can say here many to many. I'll write it here in the margin, like this would be a, let's say, favorite artist. Right, and this is many to many because there can be many users who favorite one artist, and one user can favorite many artists. So there's a many to many relationship there, right? That might be something to think about. Would there be a relationship between, say, user and song? Well, you could actually have the same type of favoriting system. Like maybe a user favorites a song rather than just adding it to a playlist or something. They just press the little star button. That could be a valid relationship. So I can write that between user and song. So many to many. And this could be a favorite. And remember, I want to stress that just because I'm writing all these relationships and you didn't, like maybe you didn't think about the favoriting feature, that is okay. You're not really going to be penalized too much for it. Well, not penalized at all for it. The main thing is, again, this is just trying to get you to think about how tables can be related. And, it's just an interesting thought experiment to think about, okay, well, would I, if you're trying to implement this feature, how could these different things be related? And on the actual quiz, we're going to be checking just to make sure that you've put enough thought into it and you have a decent number of relationships. But, it's not like you need to have every table related to each other or you need to find some way that all the tables relate to each other. You don't have to worry about doing that. So don't worry. In this case, we actually will have, at least in the key, we might have all the tables related except for one pair, I think. That doesn't necessarily make sense. But again, I'm thinking that those two might not be related, but we might find a case, or you might think of a case that it could be. And the one I'm talking about is actually artist and playlist. I'm not really sure that these two would have a relationship where you'd have an artist and a playlist. So unless maybe an artist creates their own playlist and that's a feature of the app. But again, that's not something I'm going to include, but it might be useful. One of you might think of a good relationship between those two things, and that would be perfectly valid as long as you kind of give a short explanation why. Okay, let's choose a more simple one, like artist and song, right? Well, it does make sense that a artist sings a song, so there's obviously a relationship. What type of relationship could there be between these two things? Well, we have a song is sung by an artist, right? And an artist can sing many songs. So if I were to put one to many here, that would be perfectly valid, where there's one artist for multiple songs, and every song has just one artist. Now, you could also argue that there are collaborations between artists, then maybe you'd want to have a many to many instead to account for that. Like maybe one song is sung by two people. Then you might think a many to many is better. And so again, it depends on what you come up with, and either answer is perfectly valid. I will keep one to many actually just to show the foreign keys and how that works, but many to many is also perfectly fine. And then I can think of relationship between song and playlist. Well, of course, a playlist can have many songs in it, and one song can be part of many playlists. So it might make sense for a many to many to be here. Many to many relationship. All right. And then finally, user and playlist. Well, we have, a user can create a playlist and they can create multiple playlists, but a playlist is really only authored by one person. Now, there might be a case where, again, you can share playlists, but just for the sake of it, I'll write a one to many here. So this will be one to many. One to many. And I'm going to now add my primary keys, because that is always useful to include, is an ID. And we'll call all these IDs. And of course, foreign keys, we can think about this next. So anytime there's a one-to-many or one-to-one relationship, you would want to think of a foreign key. And so again, here's a one-to-many. What is the many-sided relationship? Well, we said that there can be many playlists for one user. So we'd want to have a foreign key on the many side. And so this can say, since we're connecting it to our user table, we can call this user ID. And I can look at the other one-to-many relationship, which is right here. And I have artist and song, and I said that one artist can sing many songs. So the song table is the many side of the relationship. And I can write here, for example, artist ID. Just like that. And now I can fill in the rest. So let's say user, I can use the same standard, right? First name, last name, and email, right? Artist might have a first name, last name, and maybe, I'm trying to think of what else. Maybe they have like a URL for their website, so I could put URL. Song, of course, songs have titles, a title, and then maybe they have a description. Well, description might not be the best. Maybe instead, a description's fine, but I'll use maybe length, like duration of the song in minutes or in seconds. And then playlist, I can have a name, and then maybe I can have a photo URL if I have a photo for my playlist. And so finally, I can type all these. I forgot to write ID here. I can type all these. So this would be an int. This would be a string, int. And I can just carry this through. There we go. This can be an int, string. Also, notice that for all the IDs, I am putting int, but it is perfectly valid to have a string PID. That's actually something to remember. So make sure you remember that PIDs don't have to just be, primary keys don't just have to be integers. They can be strings too. I'll call this a float. And then this will be an int. And there we go. That is a diagram between 4 tables. And I have 5 relationships here. You may have more, you may have less, and that's perfectly fine if you have less. Just make sure that, for the most obvious ones, like, artist and song, that would be a relationship you probably must have, or like song to playlist, that would be really important, or user to playlist. So I would say that these 3 are probably the ones that are the most critical to include, this one, and this one. And the too many's regarding favorites, that's just an extra thing. If you think about it, and you may have included it, may have not, but it's fine either way. All right, and this is the challenge question. So this is the final question, and this is going to be designing the backend database schema for the TA application system. So this is for people who want to apply to be TAs for different classes within the computer science department. By the way, I guess this is just a little bit of an aside from this, but I highly recommend. I'm sure that the applications will be opening soon. So if you're interested in being a TA for 590 or any other course, definitely apply, because it's really fun and it's a great way to give back to the CS community. So, that's a bit of an aside. Maybe check out and look out for the TA application form later this month. But this one has 5 tables. So again, I said that on the quiz, you'll have to work with 4 tables. So 5 is 1 extra, which is why this is a challenge question. And these are our tables. We have student, which represents a student who'd be applying to be a TA. Term, which is referring to a semester, so like fall 2024, spring 2024, etc. And then there's a typo here. So this is course, represents a single course. I guess for a class is also part of the typo, right? So single course. So that would be like Comp 110 or Comp 423, Comp 311, etc. And then we also have a single section for the class. So it's important to think about how classes work, right? We have a course and then we have multiple sections. So like, for example, Comp 110 is a course, but we have the 1 2 and 3 sections, right? We have 3 sections this semester. So in spring 2024, we have 2 taught by Professor Burns, and then we have a professor, I guess the third section is taught by Chris Jordan. So, that's kind of the reason why it's important to think about this, is because when you're applying to be a TA, you apply to a section rather than a course, because there might be a professor that you want to work with, and so you choose a specific section. And so then we have a section table, and then we have the application table, which represents the application that a student used to apply to be a TA. All of the other tasks here are the same. So we have 5 tables now. This is a little bit more complicated, right? We have now terms, applications, students. How could all these things connect? Well, I'm going to pick out the first one, which might be the most obvious starting place would be application and student, right? So a student is going to submit an application. Now, putting a one-to-one relationship might be valid here if you're saying that a student has one application. Actually, no, this would not be valid. What I meant to say was one-to-many. Yeah, so one student can have many applications. And that makes sense, right? If I am applying to, Comp 110 and then maybe 210, I might represent those as 2 different applications. I could also say, though, that maybe an application is just one application for the semester, and that has multiple courses. But it is, of course, important to remember that you can apply in multiple terms, right? So, if I apply last semester or this semester, I'd be maybe submitting multiple applications. So I guess here a one-to-many makes a lot of sense. I don't think there'd be a situation where you'd have a many-to-many where, like, one application has multiple students on it. I don't think that would probably happen. So we can write one-to-many. And I think that makes sense, right? Where our application has, applications connected to one student's connected to many applications. Then we might think about the other connection, which might be a little bit easier to think about, section and course, right? So remember we talked right here about how we have, with 110, we have one course can be mapped to many sections, right? And every section is mapped to just one course. So this would be a textbook one-to-many relationship. So we can include a one-to-many here between section and course, right? So one-to-many relationship. Great, so now we've connected these tables. Now, where does term fit in? Well, is there some relationship between term and the application that we submit? Well, I think it makes sense, right? If I submit an application this semester, and let's say I get accepted, and then I want to apply this semester after, I'd be submitting an application with I'd be submitting a new application for every term. So it makes sense that, we'd have a relationship here between term and application. Now, it is important to think about, and it might be tempting to put a one-to-one here, but if we put a one-to-one relationship, of course, we're saying that for every term, there's only one application, which is not necessarily the case. Of course, the CS department probably gets hundreds of applications. So this would be also a one-to-many, where for every term, you have many applications, but every application is valid for just one term. So that might be a good connection, one-to-many. Now, could there be a relationship between term and section, right? Well, I think that also makes sense, because if you think about it, in a history, like fall 2024 might have 2 sections of Comp 110, spring 2024 had 3 sections of Comp 110, and those sections are linked to a specific semester. So we can write a relationship between these 2 items. And I think it makes sense that because every section, we are going to connect it to a term, and there's only one term per section, we can say one-to-many. Now, there could be some argument that you could maybe have sections linked to multiple terms, like Comp 210-001 linking to multiple terms, but I think it's also perfectly fine to just have different rows for every section for every semester, so one-to-many is good here. All right, and now we were thinking about well, how does my application connect to the actual classes that I'm looking for, right? Because ultimately I'm submitting an application to be a TA for specific courses. So it might be tempting to connect application and course, and there could actually be some justification for this relationship. However, for choosing the courses that we want to TA for, remember that because we can have different professors for different sections, we ultimately are choosing we're ultimately choosing the section that we're applying to based off of or we're applying to a course based off of the section, right? We're ultimately applying to sections. So it might make sense to add a relationship between application and section, right? And so between application and section, well, I'm applying to multiple sections, right? Because you can stack rank your choices. So I can say maybe first choice, right? I want Comp 590, right? Maybe my second choice, I want Comp 311, etc. So I can choose multiple. So one application can have multiple sections. So one application can have multiple sections. But also a section can have, one section can have multiple applicants, right? Because if let's say there's 20 people applying to be a TA for one section, then you have that relationship. So ultimately we have a many to many here. Many to many. And I think this looks great. This is mostly done. Now you could also there could be some argument for a relationship between application and course that's like, well, in my application, maybe I need to list the courses that I previously was a TA for. And maybe it makes more sense in that case to connect to courses rather than sections, because it's like, I TA'd for 210 before, so then I'd be qualified to be a TA for 210. And that's more general than just one section, right? Because the course content should be relatively similar. So maybe instead I link it this way. And so that could be a valid relationship if you included it. So I can I'll write that. Except this is another one that's probably not as obvious. So if you didn't write this, that's perfectly fine. I'll just make a note here that this is maybe for previous courses that a student TA'd for. And you can see the way I wrote it, it actually could even be justifiable that course and student have the relationship rather than application to course. In fact, I might even like that better. Previous course that students TA'd for. So honestly, maybe I change the relationship from course and application to course to student. I think that makes more sense. But of course, that's an example where you can justify it either way and it would probably be fine, right? So this is I'll mark this kind of with a yellow, like this is not really one that's too important. But that looks good. We have, you can see we have multiple relationships here. Again, the more obvious ones that we'd be looking for though, and like if this was a quiz question, it would be like section to course, maybe application to section, and then application to student, right? And maybe term to section. Some of the less obvious ones might be this, this one-to-many between term and application, definitely between course and student. Those would be less obvious. So no worries if you missed those. We will finish this up by adding IDs. So ID, and ID. And then for my relationships, I have a one-to-many where I have many applications for one. Yeah, I did it right. Many applications to one student. So I could add a foreign key that's like student ID. I also have a one-to-many here between term and application, and we said that there's one application per term, but many terms per application, so the many side would be here. And so I could put term ID as another foreign key. And I think that's all the one-to-manys with application. There's also one down here between section and course, and we said that the many side was section. So I can write a foreign key that's like course ID. And then I can fill in the rest. So students, did I do one-to-many here? I think I missed this one. There's also, a section is just linked to one term and it's on the many side of the relationship, so I can write that. Term ID. In fact, this piece right here, I'll highlight it. Course, section, and term. This is the exact relationship structure that's currently set up in the academics feature on the SysExcel site. So I highly recommend checking it out. This is the same type of relationships. We have a one-to-many and a one-to-many. So I recommend checking it out if you would like to see how that's coded up in SQL Alchemy. Let me finish this up. So maybe term, I have like start date, end date, and maybe, what else could I put for term? Maybe I can put like number of weeks or something. Section, I might have a name. Or I guess a section number makes the most sense, like 001, 002. A course has a course code, a course number, like 110. And then it also has a description. And then student has a first name. I'll just abbreviate it for now, since we've used this many times. An application, maybe I have, there's so many different fields we could have here, but maybe I just put a essay response. And of course the types, we can just say like int, date, int. Okay, number is actually a weird one. So with number, because our course numbers are like, our section numbers are like 001, 002, 003. If we were to put this as an int, that's fine, except we would lose our leading zeros. So it actually might make more sense to codify this as a string. And then our IDs are all integers. We have an integer, string, string, and string. String here for course number for the same reason. Although with course number, it's probably, there's not too many cases where there's a leading zero. Int, string, 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 int, string, int. There we go. So this would be a valid response to that question. And of course, this one's much longer. You will not have to do this on the quiz. On the quiz, the maximum that you'd get would probably be something like this with four tables. And that is pretty much it. So I know this video was quite long, but hopefully it was a bit helpful in seeing how we can think through these type of problems and how, we set up our foreign keys, how we use IDs, the different types of relationships, and hopefully also help to clarify some of the expectations for the actual quiz. Again, I want to emphasize and I want to stress that the grading for this will be more lenient. There's going to be a lot of partial credit. So do not stress about this question. Again, the point of quizzes, and I know a lot of classes, you may have tests where it's just like, try and give you something impossible with very little time, and then everyone fails, and then it's curved up anyway. That's not really the point here. The point of a test and a quiz is to really just, see and to assess your understanding of not only specific course content, but also applying general themes of a course, right? And to see how are you in terms of, learning the things that are kind of the main goals that the course is trying to set out to teach you. And one of the main things of Comp 423 that hopefully you will get out of the course, not only through these type of questions, but also just in general, and you'll find this maybe in internships and in your job and working on side projects, is being able to take an idea, such as, a TA application system, or, maybe you're making a music app like Spotify, and taking something like that and taking a problem, taking an idea, and really breaking it down and thinking about how would I design an application for this, right? Design is not just front end only. What we're doing here, this is design, right? Back-end design. And it's called, specifically system design. And so ultimately, that is the main thing that this course is trying to help you gain the skills with. And you'll find that even after the course, you'll forget maybe SQL Alchemy and Fast API, and you won't remember all these specific things. However, hopefully, you will remember how to take a problem like this and break it down and think about how would I design a backend system or just a database system for what I am trying to do? How would I model the type of data that I'm trying to work with, and how can I store that and retrieve it for later? Right, so that is kind of the overall theme of the course, and hopefully something that you will take out of it as you kind of move on beyond the course too. And that's really all we're seeing. We're just seeing how we're just going to assess through these type of questions how what your thinking is like, and how you are coming and approaching a new type of problem, and how you design something. You all already have ample experience with this, with Sprint 0 and with the exercises and the sprint you're working with. You're all working with these new problems that no one has tackled before, right? It's not like any of us, even TAs and people who are in the class last semester, a lot of these final project ideas are completely new. And so you're tackling them on your own for the first time. And you are working with a lot of this type of ideas of taking these questions and really breaking it down. Right? So do not stress about it. As long as you follow, the instructions with the arrows and the fields and everything, and as long as you put a good effort in, I have no doubt that this will go really well, and hopefully it might even be interesting to you in the type of question that we'll give, and maybe thinking about it, and who knows, maybe it won't be so bad, right? Also, another thing that I was going to mention, that Chris was going to mention too, we forgot because we were running out of time for the eclipse, is that these type of questions are actually very, very prevalent in interviews as well. Sometimes employers will ask you, something maybe specific to their company, or just something more general, and say, okay, well, I'm trying to design a feature for this, maybe something as simple as like ordering lawnmowers or something. And how would you design a database? Like, how would you design an app for this? How would you design a system? And these are the type of things that you can tell them and you can show them. And you have the skills now based on this class, based on these, this practice and other things. You have the skills to be able to tackle these problems now. And so I hope that the confidence that you have gained through working through the sprints, as well as hopefully through working through this exercise, will help you feel more comfortable with these type of questions, not only on the quiz, but also going forward. All right, everyone, thank you for listening. I know this video is very long, and of course there are timestamps, so hopefully if you needed to skip around, you could. This will be linked in the Canvas announcement, as well as the final PDF that I've worked on here. If you have any questions, feel free to come to office hours, and we would be happy to help you. Good luck on the quiz, and I know you all will do great, and I hope you have a great rest of your week.